Hello everyone. Today again we are going to learn how to use sine, cosine and tan rule or ratio effectively to solve problems. As I said in the previous lesson, it is always good to write the SOH toa and to find out which of these ratio is effective. It is good, not is good, it is the most correct, is the correct one to use. According to what we have given in the problem. So here we have a problem, we have a regular pentagon, is inscribed inside a circle. See, inscribed inside the circle or cyclic pentagon, which means all the corners of the pentagon are at the circumference, all right? All of them. It is a regular pentagon, as it says, and the radius, the circle of the radius is 5 centimeters. Find the length of one side. So now a regular pentagon. What are the properties of a regular pentagon? So what do we know? All the sides are equal. The other thing we know, the angles or the angles are equal. So sides are equal. I'm going to label them like that. And the angles are equal in a regular pentagon, just like that. Okay. Now, this is a cyclic pentagon. We need to find out the side. And we are going to use one of the ratios, sine, cosine, or tangent ratio, which means we need to have a right angle triangle. Okay? Now, so what do we need to do? We also have given the radius. And the radius, of course, is given for a reason. So we are given a radius. Why don't you draw a radius? This is the radius, all right? And then straight away, you think, well, but I can draw another radius, just like that. And so what do we have here? We have here a triangle, which is not any triangle, because the radiuses are equal, and that means this triangle is an isosceles triangle. Because this is 5, is an isosceles. Okay, what else do we know from the isosceles triangle? If we draw the height, okay, that height not only is going to divide the base, so the height from this point O, which in this case is the circle, the center of the circle. So this height not only is going to divide this side or the base of the triangle into two equal parts, but is going to create two right angle triangles. So just like that, okay? And then, so what do we have in here? Then we continue with the SOH toa. So we need to find out now which of them are we going to use. Right, the first one, so eventually we have the hypotenuse. So the tangent one, we're not going to use it, all right? Because we need to have a side that is known. So it is between the sine rule and the cosine rule. So sine this angle here. Okay, another thing that I should have shown you before we come to this bit of the problem. So if we continue drawing the radiuses from each corner of this pentagon, then what do we have here? We know the rule. Angles around a point add up to 360 degrees. Okay, now this is the pentagon. So all these angles, the 5 angles created here, are equal. So one, if I label this one as A or B, so A or B, angle A or B, and you can use a calculator if you want. So angle A or B is going to be 360 divided by 5 equals 72 degrees. So angle A or B equals sine of the angle here, 360 degrees divided by 5, okay, equals 72 degrees. And this is from the rule angles around angles around the point. Around a point. You need to always write the reasons in geometry for whatever steps that is not clear why you're using this step. So, so all this one is at 72 degrees, and that means if you label this point here, the H, that means angle AOH equals to HOB. Or I'm going to label this, the little ones here. So this angle here is equal to this angle here. I'm going to label them as angle A lowercase, okay? And angle B lowercase. So angle A equals angle B equals 72 divided by 2 equals 36 degrees. And again, because OH, height, is a height, okay? We drew that ourselves. Height of isosceles triangle, AOB triangle, triangle AOB, and you have to clarify why AOB is a isosceles triangle. So triangle AOB, AOB isosceles. Isosceles because OA equals OB equals radius, all right? Just like that. So A and B are 36 degrees. Why don't you label? Put this in the picture here, just like that. Right, so which of the ratios are we going to use? Is it going to be the sine ratio or the cosine ratio? So let's have a look at the first one. Sine 36, yes, we can find the sine 36 hypotenuse. We have the hypotenuse, yes, exactly. Hey, sorry, is this one here? Oh, the opposite, so HB, the opposite. So this is the one that you need to find. So put a little dot here, okay? For the cosine, we can find the cosine 36, you can use a calculator. Is the adjacent, so it's OH. We don't know the adjacent, we know the 5. As I said before, the one with 2 ticks and the unknown, the side that we need to know, that is the right one. So in this case, it's going to be the sinus ratio. So we know from the formula, so the sine 36 equals opposite over the hypotenuse, so it's going to be HB, and the hypotenuse is 5, okay? Just like that. And to find the sine 36, we need to use a calculator. So sine 36 equals 0.58. 0.58, and it's 587 actually. So I'm gonna round it to significant or 2 decimal points. So it's 0.59. 0.59 equals HB over 5. And now to get rid of the denominator, you multiply by 5 both sides, multiply by 5, multiply by 5. And that's how you get rid of the 5. And so HB is 5 times 0.59. So 0.59, 0.59 times 5, the answer is going to be 2.95. So we are dealing here with centimeters. Yeah, so 2.95 centimeters. And that is HB. So it's only this bit here from H to B equals HB. But does the problem end here? No, it doesn't, because the question says find the length of one side, which means you need to know the whole AB. AB equals 2HB equals 2 times 2.95, okay, equals times 2, 5.9, 5.9 centimeter, just like that. And do not forget here to reason why AB is to HB. So because we already said, we mentioned it, that OH is height, OH height, okay? It's a height of the triangle AOB, which is an isosceles. So label it here. Right, just like that. So the side AB is 5.9 centimeters. So again, dealing with ratios, you need to have a right angle triangle, and even if it's not shown in the problem, you can create it yourself. You can create it yourself. So according to what the problem says. And so that's it. Thank you very much for watching my steps. Have a lovely day. Bye-bye.